Okay, so we were just about to finish question number 7. So you have your 9 to the 9th times your charge on your electron squared, and it says it's a force of repulsion of 8 newtons. So you punch it all in. Remember that's r squared, and you should get an r equal to 5.373 times 10 to the negative 15 meters. Okay, so pretty tiny distance, but that's because we're dealing with electrons. Number 8 says two identical charged objects exert a force of repulsion of 6.4 to the negative 9 newtons on each other when separated by a distance of 3.8 to the negative 10 meters. What is the magnitude and nature of each charge? So this time you're solving for Q. And because they're the same, you could write this as Q squared. So to be Q squared is equal to R squared FQ over K. And so it tells you that they are 3.8 to the negative 10 apart. 3.8 times 10 to the negative 10 meters. And don't forget to square that. And then it says the force between them is 6.4 times 10 to the negative 9 newtons. And then you're going to divide that by 9 to the 9th Newton meter squared per Coulomb squared. So 3.8 to the negative 10 times 6.4 to the negative 9 divided by 9 to the 9th. And again, that's going to be Q squared, so then you're going to take the square root. And you get 1.6438 times 10 to the negative 14. It's so tiny it makes me think I may have screwed up. So I'm going to type it in again. 3.8 to the negative 10 squared. Oh no, I guess not. I think it's right. Okay. And that'll be coulombs. And then the question says, what is the magnitude in nature? So that's the magnitude. What is the nature? It says two identical charged objects. So they either both have to be positive or they both could be negative. You'll get plus or minus when you take the square root. But it's it can't be one positive and one negative because then it wouldn't be a repelling force. So they either both have to be positive or they both have to be negative. All right, the last question. How many excess electrons are on an object with a charge of negative 4.1652 times 10 to the 14th? I have a piece of free space up here, so I'm going to do it here. I didn't talk to you about this equation on Thursday, but I did in the video. There's an equation that says number of electrons is equal to the total charge divided by the charge of 1, or number of elementary charge. So here it wants to know how many excess electrons. So it's kind of like saying if you have a whole stack of money, whole stack of quarters, and you want on the table, and you know it's like $18 and you want to know how many quarters, you could either count them one by one or you could divide by 25 cents. So here we can figure out how many electrons by dividing by the charge on one electron. So take your 4.1652 to the negative 14 coulombs divided by 1.602. There's negatives on both, so they will cancel. 4.1652 to the negative 14 divided by 1.602 to the negative 19, and you should get 260,000 E's. Done. Okay, so now the rest of the sheet after you watch the videos for homework for today, please. Thank you. See you tomorrow.